So, I've got a bit of a problem, depending on how you look at things. I keep trying to buy power stations that'll give me something interesting to show you guys on camera, but coming up a little empty. I bought the Blue Yeti thinking maybe it would turn into something that I could actually feature, and I showed opening it up, but other than unplugging it and plugging it back in, there really wasn't much to do here. It just kind of worked. And no matter how much I abuse this thing, I can't get it to die again. I've left it at 0% on my back porch for weeks now. The thing just keeps coming back to life no matter what I do. So nothing I can really do to make content out of that. One of my subscribers tried to send me an EcoFlow backup battery along with a cable to go between it and one of our EcoFlow units. Told me that it didn't work. Hey, might be able to make some content out of it. Cool, I'll feature open it up on the channel and show what's going on the inside. Nope, plugged it in, worked right away. Thanks, Sean. I do appreciate it. I promise I'll put it to use somehow. Still want to show you guys what the inside of this thing looks like. But the same thing, unfortunately, has happened again. This time with another EcoFlow unit. I picked up this 4 parts EcoFlow River 3 unit. It's a little bit smaller than the ones that we've dealt with in the past, but it does have a lithium iron phosphate battery inside of it, which means it should be good for, based on what they say in their marketing at least, up to 10,000 cycles. This thing should last 10 plus years easy. So when I saw one come up on eBay as 4 parts, it piqued my curiosity. Did somebody just overload one of the circuits? Maybe it just wasn't charging right, or maybe there was actually an issue with the batteries and something that we haven't seen yet. So, went ahead and bought it. Only paid 50 bucks. It was an awesome deal. Really expected for that price that it was going to come in and have some major defects. Went ahead and got it in. It came in the box that it was originally sold in, came with both of the chargers and even the instruction manual. Plugged it into power, of course, just to see, and the thing turned on. And it's still working 3 weeks later. I've charged it, discharged it, used it, and thought that at this point I was not necessarily out 50 bucks, because it's frankly worth a lot more than that, but at least didn't have anything to show you guys. That's until I went and tried to test the 12 volt DC port on the front here. See, this guy came with a 12 volt charger, and it's a 12 volt directly to an XT60. So I was attempting to see if this could charge up one of our EcoFlow River Pro batteries, and found that it couldn't. Not because it's not capable, but in this case, because there's some kind of a fault inside of the unit. So I've got the unit on right now, and if I go ahead and turn on the DC circuit, it recognizes that it's on. That tells me that more than likely it's not one of those overload situations that we've run into on some of the River Pro units. But when I plug in anything to it, and then attempt to give power to any other device, or even just probe the port itself, I'm getting 0 volts out. So because of that, it's not able to actually function. There are a couple of things this could be. Could be as simple as a fuse on the inside, hopefully user replaceable, so I can just pop it out, pop a new one in, and we'll be good to go. Maybe it got dropped at some point and the port actually came unplugged in the back. We've seen that these EcoFlow units are pretty modular, and usually you can take things apart. I haven't opened this thing up yet, so let's go ahead and dive in, take a look, see what it looks like on the inside, because I don't think anybody else has taken one of these apart yet either, and then go ahead and see if we can't fix that 12 volt port so that I've got a fully working unit for only 50 bucks. Let's get over to the workbench. All right, guys and gals. And yes, there's at least one gal out there. I've seen my statistics. So, taking a look here, we've got our EcoFlow River 3. This is one of their newest units that they sell. They actually do still sell these today, but it's not one of the Pro units, so it doesn't have the contacts on the bottom to allow it to plug into one of the external batteries. Similar to how our River 1 Pros had that external battery capability, but the regular Rivers didn't. So something to keep in mind if you're looking through these, the Pros generally do actually have some extra features that the regular units do not. In this case though, just going around the outside of this guy, this has a couple of things very similar to all the other power stations that we've seen. So you've got your USB-A ports here. Those are just going to be standard charging at 15 watts, nothing real impressive there. It does have a 100 watt USB-C port, so a couple of my viewers said that they wanted something similar to this, like around this size, that would put out 100 watts at the USB-C for like a Starlink satellite dish. This will do it. It does have UPS capability as well, so for your AC outlets, these can be backed up by plugging it into an AC unit and then used as a power backup in case power does go out. Switches a little bit faster than what our River River Pro units did, so these should actually be a little bit more capable when it comes to that. It does have the 2 ports here. They're good for up to 600 watt surge, but it's 300 watt continuous. And then you do have the 12 volt over here, which should be able to put out an additional 100 watts when it is working. As we discussed before, this is actually not working. So we're gonna go ahead and take it apart here in a second and find out what's going on there. On the side, very similar to the River Pros that we had before. I do like how they've redone this latching mechanism for the door. You really can't break this anymore. I mean, I guess if you put enough force, you'd break the plastic, but it's held in much more securely and not something that's just going to kind of fail. So you've got your AC input over here, and then it does have your DC input here, which is solar or car input, and that, very similar to the other units, takes, I want to say 28 volts. It says right down here on the bottom. So you've got all your AC, your inputs and outputs here. So AC, it'll take up to 6.5 amps at 120 volts. So that's going to give us around 650 to 700 watts worth of power. And then it will take, for solar input, 11 to 30 volts at 8 amps, up to 110 watts max. So it can take in about 100 watts on the solar, about 650 to 700 on the AC input side. Otherwise, it is a lithium iron phosphate battery, as we discussed before, so it's not going to be quite as energy dense as the original River units. Those nickel manganese cobalt batteries are generally much more energy dense than pretty much anything else out there, including these LFP batteries, but these don't spontaneously combust. So these are good to have in the home, in the car, good for camping and things like that. This also is something that I haven't seen before. The battery pack inside of here is apparently waterproof. So the entire unit isn't. There are still holes on the side here. This is where some of the ventilation comes through, and then it has holes right along the front face where it allows air to come into the unit. But the battery pack apparently is completely sealed and is waterproof, so that it at least is safe if this does get wet. The inverter board, things like that, those will fry, but the battery should not. So I'm interested to see how they have that laid out. I'm guessing it's a relatively thin set of cylindrical cells all along the bottom here, but until we get in here, there's really no way that I'm going to be able to tell. So let's go ahead and start getting into the bottom here. First thing I'm going to do is just press and hold the power button on the front here. This one is press and hold, unlike the River Pros, which you have to press twice. And we're going to start taking some feet off here. I already did this once just to verify that that is how they come off, and they do. They've got a little bit of double-sided like tape or glue here, but that doesn't actually hold them in. They're held in with these feet here. You can see that they've kind of got some, I don't know what that would be considered, some kind of a latching mechanism that goes into the plastic though and holds them relatively tight. So we've got these along all sides, and when I was doing this the other day, I bent one of my nails back and it hurt like a son of a gun. So I'm going to use a pair of tweezers and probably just mess my tweezers up instead, which is much better than messing my fingers up. There we go. All right, now that we look down inside of there, I've actually just got some Phillips head. That's good to see. So I'll just grab my screwdriver here. All right. So I've got those out, I think. Let's turn it over and see if they fall out. There we go, 1, 2, 3, 4. Kind of wimpy screws, if I'm honest. Although it's not like the other units where the handle, or the lid rather, was the handle. So the handle here is molded into this entire top piece, and I think there's maybe some more screws somewhere that I'm missing. Let's see. I did see there's some screws in the handle here, but I don't believe I can get to them yet. I think something else has got to come out before I can get to those. Okay, so this is starting to separate, and if you pull hard enough, it will just go ahead and pop right apart. So that's what we're looking at here. Looks like I've undone the fan over here, got it out of its mounting bracket, so that's not necessarily the greatest thing. Let me see what else I've got going on here before I break anything. So we've got a grounding point here, our fan connector right over here. I'm just gonna go ahead and pull this guy out. Oh, these are now clipped in. Fancy. They're not just gluing them anymore. We're using clips. EcoFlow stepping it up. All right, let me go ahead and see what I need to undo here to get into the unit. So it's going to be very difficult for me to show you guys this at the same time. I'll show you in a moment once I've got it open and show you what I'm actually doing here. Does this by any chance come apart? I feel like it should. I am not seeing any screws that hold it in. Starting to see the remnants of that waterproofing on the battery here, so that's kind of nifty, but I'll be able to show you all that in a moment. I think that if I pry hard enough on this top piece here, it will separate. It will separate the front faceplate so that I don't have to get my hands in there all sketchy like to try and pry it open. I don't see any screws. I'm either going to break it and then we'll have more to fix, or it's just going to come off just like that, like I wanted it to. Beautiful. And I don't think I even broke a clip. I don't see any broken clips. And if you don't see them, they don't exist. All right, there. I can pop that back in and we are in action. All right. So taking a look at this guy here, let me go ahead and see if I can get you guys down there and get it to focus properly. There we go. So just like the other EcoFlow units that we've seen, it seems relatively well built in here. They do like to use this potting compound on almost every connector to make sure you really can't get into anything. But there's a couple of things that I see right off the bat. So there are a couple of automotive fuses here, and these appear, I'm guessing, to be battery fuses, maybe, because this is our battery main positive right here and our battery main negative right over here. We do have, flipping over to the front here, at least from my perspective, we've got the plugs for this DC jack that go straight into the board. I don't see a fuse right next to them, but that doesn't necessarily mean anything. Any fuses? No, none. I don't see any fuses in there. That's strange. And the back of this is a little loose. I can't imagine it's just the port that's gone. So yeah, we'll take a little bit of a deeper dive into that. We'll see if there is something going on here. Other than that, it looks pretty box standard. I'm not seeing anything here that really stands out to me as anything that's real new or fancy based on anything we've seen in the past here. So we have our grounding point here, which goes to our AC outputs. And then the only other thing here really is, yeah, we've got our, oops, did I break a clip now? Nope, still didn't break a clip, haha. All right, we've got our DC here. Let me pull this out. Trying to get this positive off right here from the car jack. So I grabbed a pair of pliers so I can hopefully get a little bit better leverage. And there we go. Like they say, Bob's your uncle. All right, and then of course they've got a ferrite choke around this, which means you have to cut this zip tie. So they put a zip tie around that just to make sure that it doesn't come undone and start rattling around in the case. But there we go. We've got a little ferrite choke there just to hold back any kind of electrical interference from this component. So we've got half of it off there. Let's go ahead and pull the AC ports off. And we'll go ahead and take this grounding port off as well. And then we just have one communication cable, it appears, to get the front panel off. Now, as time goes on and components get smaller, things do generally get harder to take apart. So far, this hasn't been too bad, though. Very similar to the other units as far as ease of use. So taking a look here at the back side of the connections, so we've got our AC ports right up here, along with a couple additional components that we don't normally see on the actual ports themselves. We've got our DC port jack here, rather. This is loose, which is weird. I'm not used to seeing that on a DC jack. Usually they're really, really tight. And then up front, this is just some of the control components. So this is going to be where your power button is, where your buttons are to turn on and off some of the other components like the AC and DC ports. And then it looks like we've got a antenna here. That's an Express RF ESP32. So yeah, this is the Wi-Fi, as well as probably all of the firmware is right on there. Because it's an ESP32 and we actually have some headers here, this one's probably one of the easier ones to hack. So you could more than likely rewrite the firmware on this guy here. ESP32s are a very, very common board that are used by makers to just make your own projects. In the past, I've used them to make lights that I could turn on and off with a virtual assistant versus having to do them myself before they got real popular. So yeah, a lot of capability there. That'll be interesting to see. If I get a chance to get another one of these that's maybe broken, we might be able to explore what can be done with the ESP32 in there. Now this is going to be our AC board as well as our MPPT charger, it looks like. So we do have our DC inputs here, and we've kind of got this line across the board which appears to separate the DC from the AC side. So they kind of built it, again, all in one in this case. Over here we've got a couple of relays and a bunch of other components that I'm not familiar with enough to kind of tell you all what they do or what they are. Taking a look though, I'm still only seeing the two fuses here. There's a couple of resistors which they could have used as a fuse, but none of them look popped. And we've got parts on the bottom as well. So we actually need to take this guy out because it looks like our fuse for this may be on the other side of the board. That may be why our negative's going in here, and then the fuse is probably right on the opposite side of that negative port. So let's go ahead and see how difficult that's going to be. These terminals look to be the most fun. I'm interested to see how this works out. Hopefully these are screwing into the terminals and it's not a case that it looks like where they appear to be soldered in, because I'm not unsoldering those. But we do have a BMS lead here. I'll go ahead and pull that. We've got, it appears to be another BMS lead on this side. So interesting, we might have 2 banks of cells in here. And then, kind of funky some of this stuff. Like this is the cover that goes over the XT60 for the charging. And it's just a little injected molded piece that clips onto the outside of that fitting, and if it's stupid and it works, it's not stupid, so there we go. That's how I would do it if I was 3D printing something. Speaking of which, we're going to be getting into some of that here soon, so stick around if you want to see some battery projects mixed in with some 3D printing projects. All right, let's get going. We got some more Phillips to go through. All right, so we've got the last 2 remaining screws here are the battery terminal screws, and I'm not quite sure how this is going to come apart yet. Oh, just like that. Okay, so it does just sit on top of the battery. That is really kind of interesting. I've not seen this configuration yet. It's similar to how newer MacBooks do a similar thing where the battery connector from the main board actually just sits down onto the battery and then you screw it in, and that's what kind of holds everything together. So this is kind of an interesting modular design that they've gone with here. You're screwing directly into the battery terminals themselves down here in the board, and they just go through the terminals on the top of this board that carry the current to all the different components. So nifty design, I kind of like it. It appears to work well, and the traces on here are massive, so you're able to get a lot of power through that. So yeah, I'm down for it. So again, we've got our fuses right here. I probably should have checked those before taking it apart, but if I did that, then we wouldn't get any content out of it, because that's probably where the problem is anyway. Taking a look on the bottom side of the board here, this is probably where all of our DC charging circuitry is. Well, no, we've got some AC components on here as well. You can see again that line that goes around the board that separates the AC components from the DC components. So all your DC stuff is going to be right over here, and this is going to be your MPPT charger, this is going to be your USB outputs, all of that fun stuff just chilling right over here. And then this is going to be your AC circuitry that kind of didn't make it on the top of the board and had to be put on the bottom. Now, just like the other EcoFlow units that we've run across, this has kind of a shiny shimmer to the entire board here. You can see that in my light. And that is a waterproofing substrate that they put on there just to try and give it some chance of surviving if it does get water or get used in a moist environment. You'll see that along some of the areas right on the side, that waterproofing substrate kind of stops, and that's because there's just no components there to protect. So they only spray it where they really need to. So yeah, good stuff there. Taking a look, again, we've got our DC 12 volt, the jack that we're working on right now. The inputs come in right here, or the outputs rather come out right here. And the other side of the board there is completely potted up. So I can't see any of it. Gotta love it. So let me go ahead and grab my multimeter. Let's check and see if we have continuity on those 2 fuses. If it ends up just being a fuse, I don't know how easy it's going to be to get those off. Okay, they're just soldered in right over here, so those might be easier to get off than anything else. If not, we might have to try and attack some of this potting compound, see if we can get underneath this and find a fuse in here somewhere. All right, first one here, that is a good one. Second one here, that's a good one. All right, well, that doesn't tell me much of anything. So that tells me that the battery fuses are good. Doesn't tell me that anything else really is. So we know that it's not the fuse up top here, and I'm not seeing any other fuses on the board. Somebody maybe will point one out to me. I'm not seeing anything that's marked with an F on the board either, as far as any of these small surface mount components. Oh, whoa, wait a second, there's a fuse right there, but no, that's a diode, that's an LED. Yeah, I'm not seeing anything marked with an F, so an F would generally tell me that, hey, this is a fuse. Nothing like that. So unfortunately, that leads me to believe that it's probably something underneath all of this fun stuff. And I wasn't looking forward to getting into this fun stuff because they make this very difficult to get into. Yeah, I don't foresee anything good coming of this. I foresee me just stabbing myself right through the hand with a pair of something very sharp. I'm going to look up and see if anyone else has run into this issue and maybe has a solution for us that won't require removing all of this potting compound. All right, guys, so somewhat predictably, there wasn't anyone else, at least that I could find on the internet, that has run into a similar issue yet with the River 3. There's lots of complaints about this DC jack on the River 3s, but it's really just about the make of the DC jack. The type of jack that they used is not one that people seem to care for very much, which I understand. It's a little loose, and this kind of connection on the back just really doesn't make me feel super comfortable about it. It looks like it might be replaceable, but I'd have to find one that kind of fit it perfectly, and not something that I'm worried about too much right now because it's really not a jack that I use too often. I want to verify that my issue though is actually to do with the River unit itself and that it's not a problem with the jack. So I want to go ahead and put this back together and then do some probing on the board directly with my multimeter versus going through and trying to just probe the jack or plugging something into it and seeing if that works. So let's go ahead and reassemble this real quickly here, which should be pretty easy now that we know how it came apart. I'm going to press and hold. I have the front power on. Let's go ahead and push the DC power button. It is now lit up, indicating to me the DC power is on. Let's do some probing. All right, so we've got our positive here. This is our 12 volt DC positive in theory, and then our negative would be the outside of this casing. Hey, we've got 12 volts there. Okay, so there was nothing wrong with it. It's just a really crappy connector. Well, I mean, I guess once again, I've got a perfectly working power unit and some crappy content to give you guys. This is annoying. All right, let's test the jack. Let's see if maybe it is just the jack. Could be the jack. Maybe it's the jack, guys. You think it might be the jack? Since it could be the jack. All right, so I've got here a different DC jack. This one is for a Jackery power station, but it has the same port as our Blue Eddy unit. And yeah, that sucker, it's just a bad jack. Okay, so this one being loose on the back here like this means that there's no solid connection coming through. Well, that's cool. That's something I can fix. So that's exciting. That means that this is something that in theory can be fixed by mere mortal hands and does give us something to do. So what I'm going to do is we're going to take off the front panel again, because that's where all of our work is going to be from this point forward. And I'm going to get some measurements off of this port here and see if we can find one that is similar to it, but maybe a more traditional port style. All right, so I got this port out and I just wanted to show you guys what I was able to find here. So it was weird to me that the port on the back here was so loose. So even the plastic that kind of holds the positive end here, it's very loose on the end here. And then the actual connector is just kind of dangling. It's not held in or riveted like it should be at all. Now, when I took a look down inside here, and I doubt if you guys will be able to see this at all, just based on the light, but the actual post that is supposed to be the positive end for this port is melted into this plastic. So whoever had this before was definitely using the crud out of it, and they likely just used it so much that it ended up melting this port. It got so hot that it melted. So this is definitely going to end up being our issue. And again, it's a complaint that a lot of people have about this unit is just this crappy port design. So we're going to take a look and see what I can find to replace this, and I'll be back with you here shortly as we go ahead and get this fixed.
2 days later.
All right, everyone, a couple days later, but I do now have a replacement 12 volt socket, and a little bit of a beefier one, it seems like, at least. The problem we may run into here is dimensions. So this one is ever so slightly longer, and it does appear the pins come out the back instead of coming out of the side. So because of that, I'm a little worried about whether or not this is going to fit in there. It's slightly larger on the front side as well. You probably won't be able to see that, but it's about maybe a millimeter wider all the way around. So I'll be interested to see if this does in fact even fit in here first off. If it does, then we can work on the wiring, and I think that's going to be pretty easy to tackle. This has a removable positive end cap here. So I should in theory be able to take this off, pop the one on from here after I go ahead and remove that rivet. And then I'll be able to just bend this other side down a little bit so that it can plug in business as usual as it did before. So first, let's see if this will physically fit. So let me go ahead and I'm gonna flip this guy back around and let's just line these ports up, and I just wanna see how this is gonna fit in there and if it is in fact going to interfere with anything. And right off the bat, it appears it unfortunately is. So there's a large, I believe, capacitor right there. And yep, this guy runs right into it. So what can we do to solve for that? And I'm afraid there probably isn't too much of an option there. That's crazy how close that would have been before. That would have been basically touching it. In fact, I can see some area here that's a little rubbed off, and I bet you that's where it was touching. So back to the drawing board. I need to go and find another one of these. All right, guys, so I've had a little bit of fun with this. I've ordered a few of these cigarette lighter adapters that are made more or less universally these days, based on what the guy at AutoZone told me. At least not many people come in for these anymore, as you can imagine. So I've ordered a few of them off of Amazon. A couple of them had the measurements that matched the one that came off of this unit. But whenever I got them in, they were all the same exact thing. They were all the same exact piece here. The measurements were off on some of them. And unfortunately, it doesn't look like, unless I want to order something from like Alibaba and wait a few weeks for it to get in, doesn't look like I'm going to be able to find anything that directly matches this one. And that has been a complaint that I've seen when I look online about this unit, is that this is a little bit shallow, and because of that, some things like to pop out of it. I did notice whenever I was plugging things into it before that they didn't actually go all the way in and kind of snap in like you normally see. This one just has straight sides. There's no indents or anything like that on the inside for something to actually fit into. It does seem like this was probably either a specialized part or a part that they just had a bunch of them on hand, and that's what you get whenever a company has a bunch of something on hand. They just kind of shoehorn it in anywhere they can. Now, the heat buildup that caused this to initially melt down inside of here, my expectation or my thoughts behind it are more than likely just because this rivet was a little bit loose. The connection was a little sketchy, and because of that, that's what caused an excess of heat back here, which allowed this piece to melt through and then eventually caused it to become so off that it no longer is making a proper connection and able to carry power. So rather than trying to replace this component, what I'd like to do at this point is see if I can go ahead and do two things. I want to put a soldering iron on here, and I want to go ahead and try and push this back through so that the piece inside of here is no longer flush with the plastic. That'll give me a better chance of making connection whenever I do plug a device into it. And then the second thing I want to do is I want to actually solder this line directly to that rivet. I no longer want to just expect that the pressure alone is going to hold it, because we can tell just by how loose this is that that's not the case. And if this ever does get hot again in the future and come apart, or if it does ever get warm enough rather to deform the plastic just a little bit and it starts to do this again, I don't want this to be something that builds up heat and potentially causes an issue. So that's what I'm going to do as my fix for this, and we'll see together whether or not it works, or if I just completely ruin this unit and end up having to go something completely off the wall to get this working again. So for that, we'll go ahead and bring in my soldering iron. Let's go ahead and get some solder flowing here on this joint. And that did work quite well. Oh, there we go. And yeah, now the plastic's starting to melt a little. All right, so I've got that soldered to now, so it's no longer moving around. The plastic on the back of the unit here is still a little loose, and that leaves me some concern because the negative terminal isn't actually secured on here in any way. The plastic is what holds it. That's interesting. And I say interesting to mean crappy. I don't like the design of this plug. I think I might go ahead and do some destructive disassembly here so that I can put some additional solder on this negative point, because it's really all just held in by that rivet. And so once that rivet fails, you no longer have a proper connection, and that's where you get into this kind of trouble. Ooh, yeah, that's a thick, thick plastic. That's definitely some kind of a nylon. That's why it's so hard to melt, but it melted itself just fine. Now they put this on here as an insulator. I'm gonna go ahead and wrap it in Kapton tape once I get it back together to make sure that these two terminals don't have any chance of touching each other. But that shouldn't really be a concern inside of this kind of a sealed unit. All right, so I've taken enough of that plastic back. Let's see if I can get this in. Are you gonna focus for me? There we go. So I've taken enough of that plastic back that I can see that negative terminal there, and you can see me kind of wiggling it up and down there. I really wish this camera would quit doing this. But yeah, that's what's going on there. And so I'm gonna go ahead and try and solder that down to, again, just keep it from rattling like that. All right, that seems like it is now taken to both sides. I'm gonna go ahead and remove my soldering iron and let that dry. And with any luck, we'll have a semi-solid bond there. I did go ahead and I ended up putting a second coating on here because it did, when I tried to pull it apart the first time, it did come apart. So I didn't have quite enough heat in that joint for it to actually make contact. It seems like now it's good. So we're gonna go ahead and reinstall this part here, test, make sure that it's working. And as far as I'm concerned, this should be the fix that we needed. So we're back up and running here with the EcoFlow River 3. Did go ahead and get the port placed back into the unit here, and now it's time to really just test it out and see if it works. So we're gonna be working today using one of our EcoFlow units, just because I left the EB3A at home. So I'm gonna go ahead and plug this guy in. I don't think there's a light on this one, so it won't tell us here, but as soon as we plug it into the EcoFlow, we'll know if it's working or not. Let's see if we get a charge going here. Don't have this on currently, so if it turns on, that means we're probably working. Let's see. So far, nothing. That's not a great sign. My DC does show on over there. Let's go ahead and get this River Pro turned on. Oh, maybe. Maybe not. Hello? Oh, there we go. That was weird. Didn't want to turn on there for a second. Let's plug her in, see, do we get anything coming in? There we go. All right. It had me going there for a second. I thought maybe we didn't actually fix it, but yeah, there we go. We should get about 100 watts coming out of this thing. Yep, since this only accepts in 8 amps at the 12 volts, there we go, 93, 94 watts is about right. This can push out up to 100 out of that port, so that's why the solder trick should work just fine. There shouldn't be any risk of us actually damaging anything. And sorry, I just realized you guys can't see that because of the polarization of that screen, but there we go. We are charging 93 watts currently going into it straight out of our other EcoFlow. It shows an output here of 104 watts. So there is a little bit of conversion loss there going from the 30 some odd volts of the DC battery in here down to 12 volts. But we have in fact now fixed this unit. So there we have it. So I would say overall, not a bad deal. Unfortunately, I wasted a couple of bucks buying these cigarette lighter adapters so that you don't have to, because now we know that these just really don't fit. You've got to find a specialized one for this unit if it does in fact completely go out. But the little bit of a fix that we employed here should keep it working for many, many years. To be honest, I really don't use this port. If I were ever to use it, like in an emergency situation, it would more than likely just be to expand the USBs and give me a couple extra USB ports that I could plug into, because that seems to be what everything runs on these days. There's very little that uses this anymore, so it's not something that I expect to use often, but it's good to know that it works. And now this unit is 100% working, and for 50 bucks, I think I did pretty well on it. Again, this thing's small enough that it can go pretty much anywhere. This might be something that I just leave in my car at 100% charge and just kind of let it chill, and use it in emergency situations when I'm out on the road. So cool little unit for 50 bucks. I'm really, really impressed with it, and I think I'm going to get some good use out of it. So hopefully you guys like that deep dive into the EcoFlow River 3, as well as the repair of that DC port here. I've got a couple other repairs that are going to be coming up here soon, as well as a couple of projects, so stick around if you want to see more. Thanks for watching.